Welcome to Episode 2 of Road Ready. In Episode 1, we chased down an engine knocking noise and isolated it to number 5 piston, or cylinder, on the Jeep 4-liter engine. In this episode, we're going to clean the upper cylinders, including the intake and exhaust ports, the piston crowns, and the combustion chambers, in an effort to reduce or eliminate that knock. We're also cleaning the fuel injectors in the process. So join us and let's get going. Before we dive into Episode 2, I'd like to qualify something. None of the episodes of Road Ready are intended to be infomercials. There are products and tools that I will demonstrate that are my choices. The purpose for demonstrating these tools is to share the kinds of tools and equipment that are necessary to perform the work properly. You can make your own choices about tools and products for your service work.
SUR&R offers a variety of products for cleaning a fuel injection or carbureted engine. The upper end cleaner can make a dramatic difference in removing carbon deposits, cleaning injectors, improving the performance of the engine. Our 4-liter Jeep engine in question
has 176,000 miles at the time of this service,
and other than spark plug changes, has never had an upper cylinder, valve, or fuel injection cleaning, and the engine is on its original injectors. We'll begin reviewing these tools with the FIC 903 intake system cleaner. The system is very simple to use and can be used on a carbureted or an EFI engine. The canister is filled with proper cleaning solution, and we will be using Seafoam in this case. The cleaner is drawn into the intake system below the throttle body or carburetor, so the system is ideally suited for either type engine. The hose attaches to a vacuum hose at the intake manifold, typically the brake booster hose or similar hoses. This tool is actually capable of cleaning gum, varnish, and carbon deposits from an intake system, the combustion chambers of the upper cylinder and cylinder head, EGR valves, intake valves, and oxygen sensors as well. Depending upon the solution used, and in our case it will be Seafoam, the oxygen sensor can be included in the cleaning process. Some of the claims include improved gas mileage, improves engine performance, and decreases harmful emissions.
Top engine cleaners have been around for a long time for internal combustion gasoline engines. I've been using them since the late 1960s. The difference here is the device, the FIC 903, enabling vacuum drawing directly into the engine's intake system.
The tool is easy to use. Fill the canister with cleaning solution and connect it to a vacuum line. The gauge is a very efficient way of regulating
the flow of fluid into the system.
And this is done simply by filling the canister with fluid, attaching the gauge, attaching the vacuum source, and using the vacuum of the engine itself to create a low pressure and draw the canister fluid into the combustion chambers. This tool is optimal for cleaning the intake manifold, the intake and exhaust valves, the combustion chambers, and the tops of the pistons. It's a quick and efficient system for doing all of that. This is a fuel injection cleaner kit, the FIC 203. The FIC 203 includes a canister. The air supply system can be either from shop air, which is the way we want to use it, or you can get the optional TFS 203, which is the temporary fuel supply and fuel injector cleaner that has a 12-volt pump system that provides the compressed air for the canister. The pressurized canister is adjustable, as it was with the intake manifold kit, to provide just the right mixture of cleaner and gasoline while cleaning the injection system. A full set of hoses is included. These hoses are adapters to various fuel injection systems and cover the full range of common fuel injection applications. This kit is ideal for the professional shop or serious DIY user. And I'll demonstrate the use of the tool in the actual cleaning of the injection on the 4-liter Jeep engine. This optional S tool is an intake cleaning adapter kit that improves fuel performance by removing carbon buildup. The nozzle end provides a fine mist spraying action for thorough cleaning of the air intake system. This would work at a throttle body, and if used properly could even be used on a carbureted engine down the throat and past the venturi areas.
The S tool can be handy It's universal. It'll work with a carbureted or EFI engine. The concern is engine backfire. Should the engine backfire, there's always a risk with flammable liquids like gasoline and the cleaning solutions of a fire. So be careful. Make sure the engine is in tune before using this device, and be certain to use it according to the instructions from SUR&R and also from Seafoam.
The FPT22 adapter set is actually part 2 of the FPT22 Deluxe Fuel Injection and Pressure Tester Kit for pressure testing an EFI system, or as part of the cleaning process as well. The FPT22 can accurately diagnose fuel delivery problems, find faulty fuel pumps, pressure regulators, fuel lines, check valves, and fuel filters. This is a quick way to get past the mystery of EFI tuning and EFI troubleshooting. You can make connections quickly and easily using these Quick Connect adapters. Featuring the exclusive Quick Connect adapters with thumb release, you have the push-button convenience that will enable you to quickly attach and detach the adapter hoses. We will use the FPT22 system to diagnose the condition of the fuel injection system, including the fuel pump and the injector rail. Our 4-liter Jeep engine is a single rail system, so there is no pressure regulator at the rail. The pressure regulator is at the fuel pump module and the fuel tank.
Recall from episode 1 that the rail injectors are lined up 6 in a row. This would be the same whether the system is a 2-rail or single-rail system, the primary difference being where the pressure regulator is. A 2-rail or earlier MPI system would have a return line back to the fuel tank. This single-rail system does not have a regulator at the rail and returns fuel at the pressure regulator mounted on the fuel pump module. Testing the fuel injection system would be the same for either system.
The combination of these tools enables a full spectrum of diagnostic and troubleshooting, as well as cleaning the upper cylinders, combustion chambers, and the fuel injection system. Our Jeep 4-liter engine is certainly in need of injector cleaning. There have been no engine codes, but that does not tell us the actual condition of the injectors. We did a sonic pretest of the injectors, and after cleaning the injectors and using the canister cleaner with Seafoam, we will retest the system. In our demonstration of the use of this equipment, the steps provided by Seafoam and SUR&R will be our guideline and will prove helpful to users of this test equipment. So what makes Seafoam motor treatment different? For one thing, there are no harsh chemicals or detergents. The products only contain petroleum-based cleaning and lubricating ingredients that cannot harm your engine or fuel system components. These products have been the choice of mechanics since 1942. When I was a heavy equipment operator in the mid-1970s, Seafoam was a popular product among the mechanics and fleet operators.
If you're on a budget or simply don't want to invest in the FIC 203 or FIC 903 system, there is an alternative. The inexpensive approach is Seafoam spray. According to Seafoam, the manufacturer,
Seafoam spray is a top engine cleaner and lube. It can be used without an apparatus. Seafoam spray cleans and lubricates critical upper engine areas where fuel cleaners can't reach. Cleans intake valves and chamber deposits. It's safe in all types of 2- and 4-stroke gasoline engines. Can be applied through the gas fuel injection throttle body or the carburetor throat on carbureted engines. This product also works with modern gasoline direct injection engines, the GDIs that are becoming more popular. Seafoam spray lubricates throttle plates, bushings, and upper cylinders. Can also be used to fog and protect intake and cylinder areas during storage, especially useful for motorcycles, boats, and other recreational vehicles that are stored for long periods of time. Seafoam spray is a top engine cleaner and lube that helps remove intake valve and combustion chamber deposits. It will work with 2-cycle and 4-cycle gasoline engines. This is not for use in diesel air induction systems. A handy hook is provided to bend the nozzle and hold it in place when cleaning the engine, and complete instructions are furnished on every can, suitable for use in small engines and any 2-stroke or 4-stroke gasoline engine. Seafoam spray can be used to hot soak the engine, and a restart will clear deposits built up in the engine. With any of these products, always make sure you restart the engine in a well-ventilated area, as the exhaust that comes out with all of this debris may be extreme.
At this point, we're all thoroughly versed on the products and the tools needed for cleaning the upper cylinders and diagnosing trouble with the fuel injectors. We're going to move on and get our hands into the job. The first step is to take an inexpensive scan tool that can read live data and read the fuel trim, and try to associate the fuel trim readout with the actual knocking of the engine before we begin the cleaning of the upper cylinders and the fuel injectors. There are no lower end bearing noises. Oil pressure is excellent. Once stored troubles have been ruled out, the focus will be live data. Spark time in advance, map readings, sensor data, and fuel trim in real time will be valuable. Listening to the engine while reading this data can help tie performance to the cause of this engine noise. Listen for the engine noise. In the background, you can hear the knocking noise that we heard in episode 1. We had narrowed this down to the number 5 cylinder and suspect piston. Recall from episode 1 that the noise in the background has come and gone for 50,000 miles, sometimes louder than other times. Persistence and a louder pitch has brought this concern to the forefront. Here, I'm watching the fuel trim while listening to the engine noise and seeing if there's a connection between the two. There are no stored trouble codes. The streaming data looks normal. 2 items of interest are the short-term and long-term fuel trim. If the engine is knocking from a lean condition, carbon in the combustion chambers and on the valves, or carbon on the piston crowns, there will be uneven combustion and lean fuel trim on some cylinders. Knock from 87 octane fuel is also possible. Clogged injectors can cause erratic combustion and fuel mixtures. The short-term trim is dancing all over at an unloaded idle. This engine noise shows up when the timing advances and fuel mixture goes lean for emission purposes. As the throttle opens and under load, this noise has always gone away. To put spark advance into perspective, spark advance is high when the engine idles unloaded. This is an emissions measure. With 87 octane fuel and 14 to 17 degrees of advance, the engine totters on the brink of detonation, or ping. Lean fuel mixtures can tip the scale toward a carbon or spark knock. That may be going on here. Keep in mind that this engine does not have a knock sensor. The up and downstream O2 sensors are doing their job, with long-term fuel trim indicating that the system is stable and emissions compliant, while likely compensating for carbon buildup in dirty fuel injectors. The SUR&R FTP22 Deluxe Kit will test both the fuel pressure and the fuel flow volume. The dual test will pinpoint a fuel tank sock issue, fuel pump condition and output, the fuel pressure regulator filter function, and rail damper if so equipped. The 1999 4-liter does not use a damper. The 1999 2.5-liter 4-cylinder engine would. The gauge hookups are very simple. The pressure line hooks to the rail pressure test or Schrader valve port. Fuel volume is the clear hose going to a safe and clean, empty and grounded metal can. The fuel pressure for this 1999 Jeep 4-liter engine, which is a single rail system, is 49.2 psi plus or minus 5 psi. The original fuel pump and pressure regulator still meet the norms at 176,000 miles. The regulator is holding well within this range. Fuel volume is ample, exceeding the factory call for a minimum of 1/4 liter in 7 seconds. There is also the fuel bleed down test that has more to do with the fuel pump module, check valve, or leaky injectors. Factory recommendation is that the system should hold at least 30 psi for 5 minutes after shutting down the engine. When turning on the key, the pump should deliver normal rail pressure within 1 to 2 seconds. These are factory specifications for a 1999 Jeep XJ Cherokee 4-liter engine. Follow the specifications for your vehicle make, model, and engine type. Check your service manual for the right specifications. Here, the fuel flow volume is right on factory specification, and so is the pressure settings. This means that the pressure regulator, which is at the fuel pump module at the fuel tank, is working properly, and that the fuel volume is adequate to run the engine at all speeds. We're reading a consistent 48 psi for fuel injectors, a pressure regulator, and the fuel pump at 176,000 miles. So let's clean up the top engine, and we'll start with Seafoam and the FIC 903 cleaner. We'll begin by filling the bottle with Seafoam. Note that by design, the FIC 903 is an intake system cleaner and not a fuel injector cleaner. We're drawing Seafoam into the engine through a vacuum hose that connects to the intake port. This is below the carburetor on a carbureted engine and below the throttle body on a fuel-injected engine. The canister bottle is now filled with pure Seafoam. Unlike the fuel injector cleaner, the FIC 203, this is straight Seafoam and not a mix of Seafoam and gasoline. For our service chore, we're hooking up the vacuum source to the brake booster line that goes to the intake manifold. This line has been disconnected from the brake booster and used as a supply line for the FIC 903. The valve at the regulator is adjusted so that the Seafoam streams from the SUR&R FIC 903 canister at the recommended valve setting of 5-inch height vacuum or less. 4-inch height vacuum worked well here. This and the nozzle orifice size provide just the right amount of flow. A screwdriver holds the throttle open slightly to keep the engine running at approximately 1500 RPM during this cleanup of the top engine. One ounce of Seafoam per quart of engine oil goes into the crankcase. The 6 ounces of Seafoam will help degum and improve the function of piston rings, valve lifters, and other oil lubricated parts. Now the cleanup of the injectors and top engine with the FIC 203 begins. The canister is filled with a 50-50 mix of gasoline and Seafoam. The system will clean the top of the engine, but this time by way of the fuel injectors. During this fuel injection cleaning process, the engine will actually run on the 50-50 mix of Seafoam and gasoline. Do not attempt to remove the fuel line without these tools. You will damage the garter spring. I prefer the Lyle tool. It's inexpensive and it works well. The SUR&R adapter set has every hose size that we would be using, including the one that's just right for the Jeep 4-liter engine. We will be running the engine on the SUR&R system. To eliminate the fuel pump pushing fuel out of the supply hose, we pull the relay for the fuel pump. We'll run a 50-50 mix of Seafoam and gasoline in the canister for the FIC 203. When we attach compressed air, we'll be able to build the pressure and regulate it with a regulator to the same pressure that the OEM fuel supply system would be providing from the factory fuel pump. Simply put, the SUR&R FIC 203 functions as an independent fuel supply system set to the exact pressure that the fuel injectors normally require. Fortunately, the fuel pump relay in the Jeep system operates just the fuel pump and not the fuel pump and injectors as some systems do. By removing just the fuel pump relay, we were able to bypass the fuel supply system without impacting the performance of the injectors or anything else. Some systems have the fuel injectors and the fuel pump operating from the same relay or circuit. Check your factory shop manual to see how your system is wired and whether you can remove the fuel pump relay and still operate the injectors. The objective is to make sure that the factory fuel pump at the tank is not pumping fuel out of the fuel supply line. When the cleaning process is done, you'll hook up the fuel pressure line once more and make sure that it is leak-free and fastened properly. Now you can reinstall the fuel pump relay. Having run the vehicle without the relay in place, there will be an engine code. You'll need to clear that code. Running the engine with a 50-50 mix of Seafoam and gasoline cleaned everything in the upper cylinders without fouling the spark plugs. There should not be an issue, and you should be able to drive the vehicle at this point. We are now interested in listening to the engine once more to see if cleaning the upper cylinders had an effect on the engine knock. To compare the dramatic difference that cleaning the upper cylinders made, listen to episode 1 and our focus on the number 5 cylinder. The difference is remarkable. This doesn't even sound like the same engine. The amplification level is the same as during the first tests in episode 1.
So let's review what we've accomplished here. We started out with cleaning the intake manifold, the upper cylinder and combustion chambers, intake valves, etc. with the SUR&R cleaner kit. Tapping into the vacuum line to the manifold, we bypassed the throttle body, the injectors, and all of that. And the very first thing that we did was clean up the top engine of any carbon or possible debris that might have been there. The results were startling. The reduction in noise was significant. We moved on from there to actually cleaning the injectors, which at 176,000 miles on the original injectors was probably a wise move, and we gained even more. Thirdly, in the process of all this, we tested the pressure on the fuel injection system and also the volume of flow to make certain that the fuel pump and the injectors are working properly. This engine sounds entirely different. In fact, so much so that I'm not in the least bit concerned about continuing to drive it without fear of a major engine failure. That said, who knows how many miles are on a 176,000 mile engine. Compression is normal, cylinder seal is excellent, and we're probably on for another 50,000 miles. That said, all of this was accomplished with professional grade tools. You can implement and improvise with lesser quality tools or less expensive tools, but you probably won't get the results that we did. The use of Seafoam was obviously a big plus for both cleaning the top engine and also for cleaning the injectors separately. We will move on to the Seafoam concentrated product that can be put directly into the fuel tank to keep the fuel injectors clean. And that will be an ongoing process. One of the things gained from all of this is the opportunity to evaluate why was the engine building up this kind of a knock situation. And there are several reasons. For one thing, we've run 87 octane fuel in this engine, which at 4,200 feet base elevation works just fine. The grade of gasoline is not as important as the additives that we are lacking in most of the fuels that we put into this tank. That said, if you were using a fuel that contained Techron or other types of top engine cleaner, perhaps we would not have developed a knock, or at least not a knock to this degree. Seafoam can actually be put in the gas tank to continue to clean the injectors and the top of the engine to maintain a better running engine status. And that was a prime lesson. Additionally, it's important to note that these engines, as I said earlier, do not have a knock sensor. That said, an engine without a knock sensor that's trying to meet emission standards is going to run lean and possibly, especially in the case of an inline six-cylinder engine, possibly not have uniform air-fuel ratios per cylinder. We're a lot closer with this engine because it is multi-point injection, there's an injector at each cylinder, than we would be with a throttle body and TBI, or throttle body injection, which would have been a central injector, a long manifold, which on a six-cylinder engine is virtually impossible to get uniform air-fuel ratios to the end cylinders and the center cylinders at the same time. The results of our findings are really gratifying. Investment in tools is obviously justified, and the use of 2 cans of Seafoam for this entire package, including the amount that we put into the crankcase to clean things up a bit and make sure the lifters are working properly, is a minimal investment. We're pleased with the results.
Well, our work with cleaning the top engine that consisted of the intake and exhaust ports, the exhaust valves and intake valves, the crowns of the pistons, the combustion chambers, all of that added up to a big plus. In this particular case, it made a difference. And it doesn't always turn out that way, unfortunately. We'll monitor the outcome from this top engine cleaning and flush of the fuel injectors. I purchased for the shop a fuel injector cleaning machine that requires removing the fuel injectors from the rail and actually putting them in the machine and checking them for flow and comparing the flow between each of the injectors, and at the same time I clean the screens or change them. Probably will change the screens at this mileage. The end result will be clarity that the fuel injectors are functioning flawlessly. We'll monitor this engine and see if the noise has gone permanently, if it comes back, or what. We'll go from there. In any case, this was a productive session, and I'm looking forward to episode 3 where I will tune the engine. And we'll do a thorough tune-up, and I'll talk about tune-up in the day and the difference between that and tuning a modern engine. And we'll see what we can do with this Jeep engine, which is a facsimile of any internal combustion engine requiring a major tune-up.